This video is going to be the last one in our stoichiometry calculations, and this one is going to involve solutions. And we're going to be looking at molarity, which is capital M. And molarity equation that we use is moles of the solute per liter of the whole solution. So first we're going to just do a calculation where we're going to find the molarity. So I have in this one 18.5 grams of potassium carbonate and 100 milliliters of solution. So if I wanted to calculate the molarity, I have to find my moles. Well, right now I have grams. So 18.5 grams of K2CO3. And if I want to find moles, I'm going to need my molar mass. So I'm going to add 2 Ks plus a C plus 3 O's. And I'm going to need all those masses from the periodic table. And then times 1 and divided by that number. Okay, and I'm just going to leave that out quite a ways. Okay, so that's my moles. So molarity is moles, which I just found, divided by my liters, and I have 100 milliliters, so that is 0.1 liters. And I have 3 significant figures and 4, so 3 is the least, so 1.34 molar. Okay, so I just have one substance. They usually give me grams, or they could give me moles, and they have to give me my total liters of my solution. Now they could give me a molarity, and they could give me the liters, and they might ask me to find the grams, which I could do. But you just have one thing. Well, sometimes we're going to see this in a stoichiometry problem. And in this case, they wanted me to finish writing the equation. So I know this is going to be a double replacement, so those two will switch. So the K is going to go with the NO3. Those add up to 0. And then the AL is going to go with the PO4. And those ones add up to 0. So I have 1 AL, 3 of my NO3s. Now I have 3 Ks, 1 PO4, and 1 PO4. So it's all balanced. And in this problem, they told me that I had 50 milliliters, and this is a 1.525 molar solution. And they're asking me to find out how many grams of this product that I can make. So in our normal flow, we went from grams of A to moles of A, then we went to moles of B, and then grams of B. That's what we've been working on in our last several videos. Well, in this case, instead of finding our moles from grams, we're going to be using our molarity and our volume to help us find moles. So instead of using grams, we're going to be using our molarity and volume to help us find moles. And then we're still going to do our mole ratio, and we're still going to find grams. So we're just going to have a different starting step. Alright, so I have a molarity, which is 1.525 moles, and this is K3PO4 per liter. That's what molarity means, moles per liter. And I happen to have 50 milliliters, which is 0.0500 liters. So my liters cancel. Alright, so now I have moles of K3PO4, and they're asking me about this AL. So 1, because that's my coefficient. And then my K3PO4 is also 1. And then molar mass. So 1 AL, 1 P, and 4 O's. And 1.9536 grams in 1 mole. The AL PO4. So multiply the stuff on the top. And on the bottom I just have ones. Lots of significant figures. This one had 4 and that one had 4, so I need 4. 9.299 grams of AlPO4. Alright, so the only new thing here was having to use my molarity first to find grams. Now this could also be going backwards. They might give me grams and then I would just work backwards. I'd have to divide by that molar mass, then a mole ratio, and then do my molarity. Okay, and the last kind of problem is still dealing with molarities, but this one they've given me molarities and volumes, but not asking me to find grams. So what that means is, just like last time here where I started, I'm going to have to start with my molarity and my volume. But instead of finding grams, I'm going to be hopping out here, and I'm going to be doing the molarity and the volume equation again over here. Liters. Okay, so I'm going to be doing molarity equation, mole ratio, molarity equation. Okay, so I have 0.550 molarity, which is moles per liter. And I happen to have 183 milliliters, which is 0.183 liters. Okay, now they are asking me about this term, because that's the thing I don't know. So I have 1 mole of the H3PO4, and I have 3 moles of the KOH. Alright, now I'm going to do my molarity again, and I have 2.02 molarity, which is moles over liters. This is moles, so the moles has to go down here. So everything cancels out except for liters. So 0.55 times 0.183 divided by 3 divided by 2.02. Now that's liters, and they've asked me to find milliliters. 2, 3. So 16, that has 3, they all have 3, so I need 3, 16.6 milliliters of the H3PO4. So that is how you're going to be using molarity in your stoichiometry equations.